We have the question: a cricket ball is thrown at 45 degrees to the horizontal with a kinetic energy Ke equals to K. At the highest point, what will be its kinetic energy? So, this is the horizontal direction x and vertical direction y. Here, we are throwing a ball and it goes to some point, highest point, and then again goes in the downward direction and finally reaches the ground, right? So the velocity of projection is along this direction and let it be v. So it is projected at an angle 45 degree to the horizontal. Okay, in this direction we have Vx and we have Vy. Okay, so if the initial given velocity is v, vector v, then along horizontal you have Vx equals to v cos 45 degree, which is v by root 2. Similarly, along vertical direction you have velocity Vy equals v sin 45 degree, which is v by root 2. So it is going up and up here, and all throughout its journey it is experiencing a pull of gravity. So, and this is in the vertical direction, pull towards the ground, and while it is going up, it is also going in the horizontal direction, and there is air resistance opposing it. It will reach a maximum height because of the gravitational pull is there. So what will happen at the maximum height? It will not have any more vertical velocity. It will only have, so this will not be there. Okay. There will be only Vx. Vx only will be there. So what we write is at highest point, which is where we require the kinetic energy, V is equals to only Vx, since Vy is equals to 0. Otherwise what we would have had at any other point, V is equals to magnitude of the velocity is equals to root over of Vx square plus Vy square. But at the highest point we have only Vx, since Vy is 0. So the kinetic energy there at highest point will be simply equals to half into mass into v square, and v is Vx and Vx is what? V by root 2. So what we have is 1 by 4 m v square, right? We are given the information is the ball is thrown with kinetic energy k, right? And so in terms of k, what we can write, this is the initial kinetic energy, and k is equals to half mv square. This was the initial velocity magnitude square, and we have kinetic energy k equals to half mv square. So now at highest point, the kinetic energy is 1/4 mv square, so it is k by 2, right? So that is your answer.